is it easier to take, say, a chemical engineer and train them on CFD, or take a computational engineer and teach them chemical engineering while on the job?
I see what you mean.
What do you see as the more typical user profile?
Yeah. My personal bias is towards the former. Okay. And actually, I'll go as far as saying that my experience biases me to the former. It is much easier, in my opinion, to teach somebody who's solid in the fundamental engineering disciplines, be it chemical or mechanical or civil or aerospace or whatever it is, electronics, semiconductors, and expose them to a competent and literate use of simulation tools than to flip the game.
A computer scientist would find it very difficult to appreciate the chemical,
because they don't have that physics and fundamental core background that an engineer comes up with.
Yeah. Right? So right there is a message that a good user engineer starts from one of the core disciplines and picks up the computational tool knowledge either through a formal graduate degree or through experience of using the tool somewhere. Wonderful. Let's come to the second class of engineers, the software engineers that work in the industry and create a software layer for others to use. What's the graduate profile of those people?
Yes. Again, I'm just going to, for inspiration, look at the demographics of this set of technical community within Ansys and draw some inspiration from that. So we see kind of diversity of profiles and backgrounds in that category. And by this I mean, we see people who come with very classic engineering degrees, mechanical, aerospace, chemical, electronics engineering, and all of that. But during their graduate work or their research work, they've had some definite exposure to creating software systems from ground up, right? So by this I mean, they're engineers, so they've done their progression of engineering courses, but then because of their technical work, they've also written code, right? So they have an appreciation of, one, what are the fundamentals, the building blocks of what constitutes a numerical analysis and turning it into a software system. And so they would have learned some technical computing fundamentals, I would say, right? But that does not scale very well. That's a kind of a special class of engineering graduates, right? And they come from very targeted groups where the advisor or the lead faculty member, his or her own specialization is in fact technical computing, right? So if you just point back to me, I came from the stable of Professor Patankar, and that's all his students did, right? So, but that's a small community, right? So as the software enterprises have grown, somebody like Ansys, has more than 2,000 research and development engineers, right? By the way, an almost equal number are in the technical services group. So that's that user engineering community we just talked about. But we are talking about the R&D group. So you have found that as you get more and more deep into software engineering, and then areas like visualization, user interface design, right? That we're hiring more and more computer scientists. But these computer scientists, we find are most productive when they're paired up with engineers, because then they learn to appreciate what is it that we're creating and who's it for. At the end of the day, an engineer is going to use it, right?
Sure.
Yeah.